So this video will focus on the product rule. So this rule is not too hard, but it does take a little bit of memorization. So let's go through what the rule is, and then we'll prove it. So the derivative of two functions. So we're going to take the derivative of the first function times another function. So here's how the rule works. You're going to take the first function, which is just leave it itself, and you're going to multiply it times the derivative of the second function. Then you're going to add the second function times the derivative of the first function. Okay, and the u can be out front here. It can be dv in the numerator or d dx v written this way. It's the same thing. Okay, so why? That's kind of a strange situation. So let's look at it. So let's look at f of x equals u times v. We're going to look at the derivative of f of x. And we're going to use our good old definition. So we're going to look at the limit as h approaches 0 of f at x plus h minus f at x over h. Okay. So then we're going to look at the derivative. So that's going to be the limit as h approaches 0. And I'm going to look at the first function. So it's going to be u of x plus h times v of x plus h minus, okay, I'm going to plug ux into the function now, so it's just going to be u of x, v of x over h. Okay, now it's not real clear where to go with from here. So there's actually kind of a little trick that we're going to add in here. Let me just show you this little trick and I'll explain. You'll understand in a second why I'm doing it, but for now you just have to kind of bear with me. So what I'm going to do is I'm going to take this. Now I'm going to add something into the numerator. So watch this. I'm going to take the same thing that's right here, u of x plus h times v of x plus h. Now this part is new. I'm going to add in, I'm going to subtract u of x plus h times v of x. Okay? Now if I subtract something, it is legal if I just add that same value. It doesn't change the value of the expression in the numerator at all. So I've just subtracted it and now I'm adding it. Okay, and then I'm going to subtract this value, which is minus u of x, v of x. Okay, so this is all over h. Okay, and I hope this can get smaller because it doesn't all fit in my screen. Okay, so now I'm going to do the limit as h approaches 0. Okay, so let me just highlight again what I did. This value right here is really just 0. So I haven't changed the expression from up above. I just subtracted a value and then I added it. Okay, so now I'm going to look at this term and this term right here. Notice how both of these right here have a u of x plus h. So I'm going to pull u of x plus h out of both of these. So if I pull u of x plus h out, then I'm going to be left with, in the top, I'm going to be left with v of x plus h minus v of x over h. Okay? Now if I go over to here, I can pull out of both of these a v of x. So I'm going to pull out v of x, and then what's left over is u of x plus h minus u of x over h. Okay, at least it almost fits in the screen now. Not quite. Okay, so now I'm going to look at the limit as h approaches 0. Okay, let's clean up what this is right here. So this is u of x plus h. This is derivative of v. So this is derivative of v, based on our definition of derivative, okay? Plus v of x. What is this? Derivative of u. Okay, so we've almost proven this step. Now the only thing we need to do is we need to substitute h equals 0 in here. So when I get rid of that, I'm going to be left with u of x times the derivative of v of x plus v of x times the derivative of u of x. So what this is what I just showed with our product rule. So if I take the first function u and I multiply by the derivative of v, and then I add the second function v, and I take the derivative of u, that will give me the derivative of product of two functions. Okay, so let's apply this to an example now. All right, so here's our example. I am going to take the function y equals x to the third plus x plus 1, and then I'm going to take x to the fourth plus x squared plus 1. Okay, so I'm basically going to let this be considered to be my u, and I'm going to let this be my v, which is my second function. So I know that if I take the derivative of y with respect to x, that I need to take the first function, which is u, and then I need to multiply it times the derivative of v, and then I need to take the second function and multiply times the derivative of u. Okay, so the first function, I take it directly as is, x to the third plus x plus 1. Now the second function, I'm going to take the derivative of v. Okay, well the derivative of v is going to be, using the power rule, is going to be 4x to the third plus 2x to the 1 plus the derivative of constant is 0. So that was the first part. Now I'm going to add to it v, which is x to the fourth plus x squared plus 1, and then I've got to take the derivative of u. So the derivative of u is going to be 3x to the second, bring down the 3, subtract 1 from the exponent, plus the derivative of x to the 1 is just 1, and the derivative of 1 is 0. Okay, and now we could multiply this all out and then simplify our values here. All right, that seems a little bit like a pain, but I'll do it anyways. So when I do that, I'm going to end up with 4x to the sixth plus 4x to the fourth plus 4x to the third. Okay, so I just distribute out 4x to the third. Now I'm going to distribute out 2x. So that's going to give me 2x to the fourth plus 2x to the second plus 2x. All right, so now I'm going to do the same thing, but I'm just going to add them, and I'm going to write them down below here so I can kind of see what I can add in, and I'm running out of room, so I'm just going to put the values down here, and I'll combine things after. So it would keep going over to the right, but I'm out of room. So this is going to give me plus 3x to the sixth plus 3x to the fourth plus 3x squared, okay, plus x to the fourth plus x to the second plus 1. Okay, so when I combine all that, some of these line up and some don't. So this is going to give me 7x to the sixth plus, I've got 7x to the fourth here, and I've got 10x to the fourth total. Plus I've got, let's see, I only have one of those for 4x cubed. And then I have x squared and x squared, so that makes 5x squared, 6x squared. And then I have plus 2x plus 1. Okay, so the derivative of this function right here is equal to this function.